How you doing, mate? How's your day going?
I'm alright, I'm just making thumbnails and finishing off my day's work making videos.
Thumbnails?
Yeah.
You're a YouTuber?
Yeah.
Oh, no. How many subs you got?
26,000.
Oh, do well, mate.
Oh,
Fair
what?
play to you.
What do you do?
YouTube.
No, but like, what do you do on
Yeah,
YouTube?
what content do you make?
I tell people Earth's flat and that space is fake.
Wow!
Oh, fair.
Say what?
Earth's flat and space is fake. Can you
Earth's
tell us
flat.
some? Try and inspire us.
Try and inspire you. Do you remember being taught in science class that you're on a ball going around the sun?
I do.
That came from the Roman Catholic Church 500 years ago by a guy called Copernicus. It's part of the religion called heliocentrism. So they taught it you like it was real.
What?
It's not. It's just a religion,
Really? Well,
Yeah.
just like Christianity.
if you like.
How come we're taught that is the case?
I mean, the
Really?
why isn't as interesting as the how.
Yeah.
So the way they did it is, do you know Polaris, the North Star?
Yeah.
Well, the way you measure, you ever heard of something called latitude?
Yeah.
Yeah.
Latitude and longitude.
Exactly. That's on all the maps, right? Well, the way you measure longitude, or latitude specifically, is with an angle off a flat Earth. So if you're at Polaris or below it, like at the North Pole, it's directly above you. And as you back away from it, it gets closer to the horizon, right? And the
Yeah.
angle that you measure is your latitude. Well, those lines that are measured off a flat Earth get wrapped around the ball. That's how you make the ball. See you later.
Yeah, something tells me you'll in fact not be seeing them later, Nathan. Anyway, that was just the trailer that flat earther Nathan Oakley used for his latest 4-hour video. I mean, he did manage to go through a full 3-minute video in about a grand total of about 40 minutes. Previously, Nathan tried and failed to debunk a video from PD194 about observations of the sun. There's one correction I want to add to my previous video debunking Nathan. PD194 brought up that due to the changing declination of the sun, an observer would see the sun slowly moving across the tropics in a tightly wound spiral. So when Nathan blatantly denied that, I brought up a time-lapse of the analemma. That wasn't necessarily what PD194 was talking about, however. So to make this easier to understand, I'll display a quick animation he created which shows what he was actually talking about. Thank you very much to PD194 for creating this. Now, the rate at which its declination changes won't be constant, so technically this pattern wouldn't be constant, but it is enough to help you understand. Anyways, let's see their catastrophe of a response to PD194.
Nathan, I put a video in Master B if you want to review it. It's not the one that's there. It's the one. It's the one. Not the newest one. It's the one above that. Not the one with the caricature of David Weiss. It's the one above that.
This is not a test. A nuclear attack was commenced against the United States. 15 nuclear bombs have detonated in several...
The exact height of the Eiffel Tower, and I take an angle to the Eiffel Tower. I can then determine my exact distance from the Eiffel Tower based on the angle I take. If I don't know the actual height of the Eiffel Tower, but I know my exact distance from the Eiffel Tower, I can then, with my angle, determine the height of the Eiffel Tower because I have the distance. So you have to have the size to know the distance, or the distance to know the size.
Okay, so just for the benefit of this discussion, this is akin to an elevation angle. The difference being that Brian's presumably going to describe actual measurements of actual sizes, which you can't do with the sun.
Whoa, whoa, whoa. What do you mean we can't do that with the sun? If the Earth were flat and the sun was local, you'd absolutely be able to calculate its height by just knowing the distance to its GP and measuring an angle of elevation to it. Why do you think we wouldn't be able to? It makes sense that we can't on a globe because the sun is so far away that its light is effectively parallel. So the only thing that would cause its angle of elevation to drop would be changing orientation on the spherical Earth.
But other than that, what we've got in principle is an elevation angle on screen. It is the line between the surface, in this case meeting the Eiffel Tower at its base, and the tip of the Eiffel Tower. The line from the observer to the tip versus the line along the ground forms this angle. It is that basic. It's just an angle of elevation. Elevation is with respect to the surface. The surface to measure an angle must be flat.
So you're saying we can never measure angles then? There is topography everywhere. Anyways, your claim that the surface must be flat in order to take an angle is incorrect. You just use a reference plane, or depending on the scenario, calculus as well. In this scenario, though, the distance between the Eiffel Tower and the observer is small enough to not need to account for Earth curvature.
Earth is measured flat with this angle.
No.
Outstanding. Thank you.
What?
That was Brian's logic.
Yeah.
And he tries to convince people that the Earth is flat.
No, it's not trying to
Sorry.
convince anything. He's showing a f***ing measurement, you stupid spastic clown. Who is this? Oh, it's Petey, what a wanker.
Ooh, struck a nerve already just by pointing out what Brian does? This is not going to go well for you guys in that case.
No, he's not trying to infer it. It's a fact. Are you f***ing retarded?
He's not trying to infer Earth is flat? Cool, the sky is also green, you know?
What part of his statement was inferred? He's not trying to convince you. It's not a belief. It's not a suggestion. It's axiomatically tied to the angle. You
You know what? This is irrelevant. He rants on this one frame of the video for almost 30 minutes. Let's skip ahead of his rant.
That's boring.
What's boring is the fact that I waited over 30 days for this full response to come out because at first, you only covered the first 29 seconds of his video over the course of 20 minutes. And yet, even in the full response, you guys aren't able to debunk his video at all.
This time he's trying to use trigonometry to prove his case. Trigonometry might sound scary, but it's all just about the relationships between the sides and angles of a right-angle triangle.
The one that you've just said that he's inferring. It's on screen. You've said that he's suggesting that it's a surface that's flat rather than it being exactly what trigonometry deals with, triangles. So where's he wrong?
The entirety of Brian's video, although no longer available, was trying to debunk the globe with trigonometry. He has a similar video here. As for where Brian was wrong, you're about to see.
Well, all you've done is in the last 20 seconds confirm he's correct.
You are totally wrong.
So how do I know that the tangent of this angle equals...
Sorry, tangent of what now? What tangent of what? Where's the tangent to anything? There is no tangent on this demonstration.
Okay, you know what? You know what?
It's a different tangent he's talking about. It's not a tangent to it, it's a different one.
Oh, thanks, Brian. I guess.
this? Let's compare the opposite side with the adjacent to see why.
Sorry, are we doing this on a curved surface? We're not. We're doing it on a flat Earth.
Any evidence that this is taking place on a flat Earth? Like I said, the distance there is too small for Earth curvature to take any significant effect. But even if the curvature did have an effect here, you can still measure an angle of elevation to the tower. You just wouldn't be able to calculate an accurate height for the tower unless you applied corrections.
Can anybody tell me how this is anything other than being dealt with ipso facto, axiomatically flat? Am I missing something?
Yeah, the entire point of the video.
Hello? It's not rhetorical.
I doubt it.
I do not doubt. I know this is flat. It can't be anything other than flat. It is flat. He's now asking us questions about the flat Earth prerequisite distances, angles, and measurements that are flat.
Angles, therefore flat, does not mean anything. As usual, I'll just skip over bits where they're not saying anything or just repeating the same thing.
Yeah. He's now going to lay out exactly what a triangle is after inferring that I tried to say a triangle used as an elevation angle across the distance on the Earth is it needs the Earth to be flat.
No, angles don't require Earth to be flat. You know, it would only take you guys 4 minutes of your day to watch this video on your stream. Oh wait, I forgot. That 4 minutes will turn into 40 minutes.
So I don't know where he's going with this, but I have a feeling he's going to go to tangent at some point. Tangent to a sphere, like not the tangent he's talking about there.
So why don't you tell us what is wrong with a tangent to a sphere?
Now, these relationships hold true no matter the size of the triangle. And as Brian just said, if you have an angle and you have a distance, then the height of the triangle is known.
Well, if you have a height and you have a distance.
Whoa, rewind real quick.
Well, if you have a height and you have a distance, you have a distance.
Brian, what do you mean no? Of course it needs to have a height. You're just denying basic geometry now.
Then you must have a flat Earth for the angle if it's along the surface to have a linear distance.
No, Nathan. An elevation angle doesn't automatically mean right triangle. It's just an angle. You can take an angle from a sphere.
So ipso facto, Earth's just been measured flat. He's just confirmed it. There is no doubt in anybody's mind.
Ipso facto, you have no idea what you're talking about. You've just confirmed it. There's no doubt in anybody's mind. Oh, wait. You've confirmed it the entire time you've been on YouTube. Never mind then.
Well, he got that a little bit wrong. He said the height of the angle, the triangle is known. No, the height of the triangle is measured. That's how you know the height of the triangle. It's measured in degrees.
Sorry, did you just say the height of the triangle is measured in degrees? And by the way, you don't just need to measure the height, you could calculate it. That is where trigonometry comes in. You just need to know the length of either the adjacent or the hypotenuse. So if Earth were flat, you could use a right triangle to calculate the height of the sun. But you can't. I wonder why.
You're measuring the opposite. The thing they want to deny exists when it comes to celestial navigation, to celestial objects. The thing they're measuring is the thing they want to deny the existence of. I don't know how to do that.
Right triangles are not used in celestial navigation. This is a lie that you guys made up. Celestial navigation uses trilateration. You do not use right triangles. You just measure angles. Then, using globe geometry, thanks again, Flatzoid, you find the distance to the GP of the celestial body. Do this to 3 stars, apply corrections, and you've now found your location. No right triangles needed.
But he said it's not the height of the triangle, it's the height of the object. When you know the exact distance and you measure the angle, which is the opposite, then you know from that, due to angular size, perspective, something else that doesn't exist on a globe.
Perspective doesn't exist on a globe, Brian? Seriously?
You know what I mean?
I'm going to go with no. Definitely not.
Then because angular size exists and the Earth is flat, that allows us to gain the actual height of the object that's small in the distance.
Yes. So why can't you calculate the height of the star using a right triangle if Earth is flat? It's almost as if it just isn't flat.
Because it's changed in angular size.
And that's exactly what we have in this scenario with this right triangle. We all agree that Polaris is generally considered to be located at 90 degrees above the North Pole. And the
Well then, welcome to flat Earth.
90 degrees.
Well then, that's a flat Earth prerequisite. He's got it described on screen also. If it's 90 degrees to the surface with a measured angle, then Earth is flat. It is. It's on screen. He's describing it. He's saying everyone accepts it. So we all accept Earth is flat then?
Yeah, no. You can get 90 degrees from a sphere.
Sorry, before you go on. If Polaris is 90 degrees to the North Pole, right, which is a point on the surface of Earth, then if we were on a globe, the only way to measure that angle, any portion of that 90 degrees would be if you were standing on the other end of the tangent, which means you'd be standing off out in space. You know what I mean?
Brian is trying to imply that if you measure an angle from a sphere, since you use a tangent line, that you'll be standing in space since the tangent only hits Earth at one point. Haha, yeah, no. Who's going to tell Brian that Earth isn't the size of a pebble? Oh, and even if Earth was the size of a pebble, you are not standing on the tangent line. Your feet would be on the curved ground, and you would just use the tangent line to measure the angle. Let's move on.
You couldn't be standing on the surface of Earth. If the right angle is at the 90-degree point, that goes, you know what I mean? There's the opposite goes up to Polaris, and the adjacent that comes out from that. If he's claiming it's a globe, then he's just claiming that the adjacent is a tangent, but you're not. The tangent is not at your feet. Your feet are on the end of the tangent that's somewhere out in heliocentric space.
No, Brian, again. You are not standing on the tangent. It is a reference. Also, stop bringing up right triangles because they have nothing to do with celestial navigation. Stop misrepresenting everything.
In space.
Yeah, it's crazy. Like,
Say something, you're so boring!
Actual latitude. Also agreed is the distance between each degree of latitude, which is about 69 miles, 111 kilometers, or 60 nautical miles. This means we have a distance and we have an angle, so Brian should absolutely be able to determine the height of Polaris. But do you see the problem? As the observer moves,
Yeah.
Polaris has to...
Are you serious? Can you actually let him finish talking?
Do you see the problem?
do I see the problem? I should be able to determine what height Polaris is due to an elevation angle measurement to Polaris, which is not a terrestrial object. It's a celestial object that rises, or at least appears to rise as you rise.
Terrestrial object or celestial object, it is still an object. And Brian, why do you think Polaris and other stars appear to rise as you rise? You know, it's almost like it's because the stars are so far away that their light is effectively parallel, and the only reason they would change angle of elevation is changing your orientation on a globe. Well, who'd have thought?
As you rise, it's as ridiculous as trying to measure an actual distance to the horizon. It can't be done. So this is the straw man they're building.
The only straw man here is when you guys keep claiming celestial navigation uses right triangles. It doesn't. There is no straw man here. This is exactly what you should be able to do if Earth were flat. But you can't do it. Oh well.
Wow, this is pathetic. I thought he was going to do something just stupid. But this is an obvious straw man.
No, it's
That's
always right
pathetic.
back to because you can't get the height of a star, you're wrong.
Bam, exactly, Uncle Ben. Since you can't use right triangles to measure the height of stars, Earth is not flat. Because if Earth were flat, you'd be able to do it. You can't.
We're measuring an elevation angle, but we don't calculate for the height. We only use the angle to gain a distance in nautical miles along the surface of Earth.
Yeah, Brian, and that is globe math. This should be quite easy for you to understand. Here is the angle measured to whichever celestial object. Since the light from the celestial object is parallel, we can have a line 90 degrees with the star's GP. And yes, Nathan, that is 90 degrees. Deal with it. You'll see that since it is 90 degrees, the line extends right to the center of the globe. And by the way, I have the radius here in kilometers, not miles or nautical miles. So like I said, here is the observer's angle to the star, assuming observer height and any other necessary corrections have been used. This is the co-altitude angle, and you will know that you find this just by subtracting the altitude angle from 90 degrees. The altitude angle there is about 50 degrees, so this co-altitude angle will be 40 degrees. Now let's zoom out. We know that since this angle here is 40 degrees, then this angle down here will also be 40 degrees. Notice that this is basically telling you how many degrees around the globe the star's GP is from you. Earth curves at about 111 kilometers per degree, and the star's GP is 40 degrees around the globe, so you can then just multiply 40 by 111, and you've found the distance to the GP in kilometers. Yes, just for this, I am using the metric system. Now, Brian, I'd like you to show us how that works on a flat Earth, because on a flat Earth, the stars would not drop in angle at a linear rate. So thank you for debunking flat Earth for us yet again, Brian.
That's what we do.
Indeed, Brian, it is.
Along the adjacent, we don't We don't claim, nobody claims an actual height of the celestial body because it can't be known.
What do you mean it can't be known? If Earth were flat, why can't it be known? You would be able to find it just by using triangles.
But anyway, that's a good point, Neil. He's mixing up two things. I don't know. Sorry, Nathan. I'm rambling a bit.
Clearly.
Physically changing its height while a 60 nautical miles distance for every degree of latitude is maintained.
Right, what's latitude? Can someone clarify what that is? Because I'm a bit dumb.
Yeah, that's the end of the adjacent.
The end of the adjacent? There is no adjacent used, Brian, because we aren't using right triangles.
So if you measure an elevation angle of 45 degrees to Polaris, then you're standing at the 45th degree parallel latitude.
Yep, globe confirmed again.
And as I recall, the Eiffel Tower didn't have to change its height when measuring to that. Adding multiple observers.
Pretty funny, huh? Want to try and answer the question?
The Eiffel Tower will still have an angular size. It's the angular size of the Eiffel Tower that we're calculating with. So it does have an actual height where Polaris doesn't. It does have an actual height where Polaris doesn't. Where Polaris doesn't.
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it.
Hey, y'all, come look at this.
It does have an actual height where Polaris doesn't.
Brian, really? Polaris doesn't have an actual height? That would mean it doesn't exist. And we know it does. Polaris is an object above us. Of course it has a height. And if Earth were flat, you'd be able to measure it.
But still, the angle to the top of the Eiffel Tower and the angle to a celestial body, whether it be Polaris or anything else, is still just an angular measurement. You know what I mean? You're just measuring that amount of space in angle.
Yes, and you don't need a triangle for that. Just two lines.
But because you have an actual height to the top of the Eiffel Tower, and it has an actual measured elevation, we can use that. But we can't do that with a celestial body because it doesn't have an actual height.
Brian, I am losing my mind hearing you say this. Yes, Polaris has an actual height.
Unless he's going to claim an actual height to Polaris. Thanks, Nathan. Sorry.
Observers to the situation just highlights the problem even more. So the idea that a right-angled triangle is formed between the observer, the ground position of the star, and the star itself has to be false because objects do not physically change in height when we walk toward or away from them.
Don't use that stuff, Pete. It's absolutely infuriating.
Yeah, he's just claimed that we're not using a right-angled triangle as an elevation angle to the celestial bodies. I don't know what, right? How do you measure the angular height of Polaris, for instance, if you're not measuring the opposite? If you don't have an opposite, then you don't have anything. You're not making any measurement.
So Brian is claiming that you can't measure an angle without having an opposite. So Brian, here I have two lines making an angle. Let's zoom out and see how long the opposite is. Still going. I'll just spell it out for you, Brian. These lines go on forever. So the opposite either doesn't exist or it's infinite. But you guys deny that infinite can exist.
Infinite radius? These mathematical concepts like infinite aren't something that can exist in physical reality.
Well, as I have explained before, the stars are so far away that we can treat them as infinite. It doesn't matter anyways, because you claimed you need an opposite when measuring an angle, and I just proved you wrong, showing that all you need are two lines of any length.
That's the exact thing you're measuring. It's a vertical, angular height off of sea level. That's what you're measuring.
Yes, Brian, so explain why we can't calculate the height of Polaris. It's because an elevation angle doesn't automatically mean right triangle, Brian.
Or you're measuring a vertical angle of height that's parallel to sea level. Either way, you're measuring a vertical angle of height, and that vertical is the opposite of the right angle triangle. They keep denying this opposite. I don't know why. I mean, is there a different special elevation angle for a celestial body? It's still an elevation angle. It's still, you're just not using trigonometry. You're using a different system because you're not using the height. You're not using an actual height.
In celestial navigation, we do not use right triangles. If you measure an angle of elevation to something, you don't need to use a right triangle.
Is stars actual, like, to the star means that you're going to the actual star, or are we talking about an apparent position?
Bro, what did you just say?
It's hard to know what he's talking about, John. From what I can gather, he's trying to strawman me because I referenced an elevation angle to the top of the Eiffel Tower. Now he's trying to say that I say that you can take an elevation angle to Polaris, and you can. But then he wants to know he wants to know why I don't have, me or anyone else, an actual height to Polaris. How do you get an actual height to something if, as you rise, that appears to rise with you? How can you get a height to it?
Oh, well, welcome to the globe, Brian. As we went through earlier, that happens because the stars are so far away from Earth, to the point that their light is effectively parallel. That wouldn't happen on a flat Earth.
If the height of Polaris at 45 degrees at sea level is 45 degrees, and at the height of the angular height of Polaris in an airplane directly above that person that's at sea level is also 45 degrees. How do you measure an actual height to something like that? You can't. It's obviously a wonder. Do you know what I mean? You can't measure that. How can you measure? I just don't get this. How can they not understand this?
Brian, you are so close, but you just have it the wrong way. Anyway, next.
If it rises as you rise, it's like expecting the horizon to stay in the same position as you rise in elevation. The horizon is always going to appear to move away from you as you rise in elevation.
That's right, Brian. The higher you get, the further the distance to the horizon is. The globe predicts that. Also, as you rise, the horizon dips. The globe also predicts that. You're doing the work for me, Brian.
Like, why doesn't the horizon stay in the same place? Because it's not an actual geometric place. Gee, bozos. Sorry, Nathan. This is funny.
Rating you complete retard. Any evidence you can acquire an elevation angle measurement to Polaris from a curved baseline? Like, why has he put a picture of Zippy up? And I'm asking about acquisition of elevation angles from a curved baseline. It's a legitimate question, and his response is to put a puppet called Zippy on screen while I say it. I'll just say it again without Zippy mimicking me. Is there any evidence that we can acquire an elevation angle measurement from a curved baseline?
You're about to find out.
Like on a globe? I'm thinking no! Yeah, and I'm correct, as now being confirmed by PT, who's showing curve angles. This isn't an elevation angle, PT.
Nathan, you have not even listened to what he is saying yet.
Nathan Oakley 1980 is yet another YouTuber that spreads misinformation regarding the shape of the Earth.
Sorry, you're showing what is suggested to be an elevation angle with a curved angle?
The funniest part is, even by your standards, this is still an angle. This is the co-altitude angle between the zenith and the light from Polaris. Both of these are straight lines. So even by your own standards, this is an angle, Nathan. Or you just don't know what you're looking at.
PT? Sorry, is it just projection? No, I haven't spread any misinformation. I asked a question about acquisition of an elevation angle from a curved baseline, and you've showed this and told your audience that I'm peddling misinformation. I asked a question. And the answer's been confirmed in this diagram, PT. You're answering my question. That's not disinformation, that's a question. It's being answered in the negative here.
Oh, can he get 90 from that curve that he's measuring?
Yes, Uncle Ben, he can.
For showing?
That's why Nathan just asked the question. You can't. Nobody's been able to show that.
So who's putting forth misinformation?
Even your little programs will tell you this object is not a line.
So I'll assume they are talking about Rob Durham here. Where's Wally has a video completely debunking that dishonesty.
And he will prove me right by instantly rejecting the basic geometry I'm about to show you.
Wait, no. The basic geometry that you're showing has a curve to the angle.
Nathan, please consider getting an eye exam. But even if he was using a curve in the angle, so what?
So when we're detailing elevation angle measurements, it's not about any geometry, it's about an elevation angle measurement. Like this, on screen. See? Shadow and stick. This is an elevation angle. There's no requirement for anything other than the angle to have a straight line, because it's an angle.
Nathan, whatever that ground distance is less than a meter. Good luck finding any effective curvature over that small distance. And of course, there can be geometry when it comes to angles, Nathan.
This is the observer, and here are their coordinates.
No. The observer would be with respect to the coordinate system and its flat, plane nature.
Spheres can have a coordinate system too, Nathan. It's on screen right in front of you, in fact.
So you're lying, you're deceiving your audience. This is pure projection. Because immediately you're misrepresenting how someone can stand on this representation, this map.
No, he is not. What do you mean he's misrepresenting how someone can stand there? Also, did you just admit that the globe there is a map?
On this representation, this map, and this map, and this map, and this map.
Oh, well done.
Now, they're not standing on the Polaris-based flat system that you described with latitude earlier. Yeah? So no, definitely not. You're the one who's misrepresenting this now, because it doesn't have an angle. That's the question that's being asked when you put Zippy up. What, so you could dodge the question that was being asked that you haven't answered? You've just put a diagram that violates that question.
Big talk. You done?
Nuts. The screen vector points straight up from this location.
That's not straight up.
That's not straight up? Want to rethink that one, Nathan?
Again, spastic much? Do you know what up means?
Yeah. In this case, away from the center of Earth.
Yeah? You've got various different outs on your ball.
Yeah, compared to each other. So what?
Up is with respect to a flat plane.
Citation freaking required, Nathan.
Well, this white one points to a very distant Polaris.
It's not. It's pointing, if you were to take it with respect to your globe surface and infer the reification of that curved surface that won't give you an angle, that isn't up. Number one, you can't even describe upon that curved surface. How's no up to reference? You need a flat plane for up, you stupid clown.
Nathan, please, just stop this. It isn't working. You aren't debunking anything.
This yellow angle is the zenith distance.
Sorry, yellow angle. There are no angles here. What's he talking about?
Nathan, I'm calling you an eye doctor. Don't worry, it's on me. Actually, maybe it's on your audience.
And if we multiply it by 60, it'll give us the length of this arc. That's it.
Ow.
That's the geometry. I've just debunked Nathan Oakley.
Incorrect. Completely incorrect. This is another numpty. Now, he's either a numpty or, in this instance, or he's being dishonest.
Well, if you're so sure, show us how he's dishonest. You guys sure did seem quiet there for a second, though.
Now, he's been both in the past with me. Mostly dishonest these days, but he has been...
Yeah, I'll just skip past him ranting about dishonesty, ignoring how dishonest they have been this entire time.
So he's trying to remove the horizontal. Well, he's either being stupid or it's dishonest. He's just trying to remove the horizontal from a 90-degree angle.
No, he didn't. He is just showing the angle that the light from the star makes with the zenith. It is called a co-altitude angle, Brian.
You can't have a vertical or horizontal on a sphere, number one. Number two, that horizontal has to be in reference and absolutely parallel to mean sea level.
Number one, you can have a vertical and a horizontal on a sphere. And number two, it only has to be level to the point of the sphere that you're standing on. It is called a reference plane.
In reality, for an elevation angle. So you can't just measure a zenith angle and multiply it by 60 and pretend nothing happened. No, the reason they measure the elevation angle in celestial navigation is so they can then subtract that amount from 90 for the remainder of that 90. So if I measure 50 degrees, then I know my elevation angle is 50 degrees, then I know my zenith angle is 40 because that's the remainder of the 90.
Wow. Good work, Brian. Now go ahead and explain how that doesn't work on a globe again.
You can't just measure a zenith angle and pretend there's no horizontal involved. That's just thick, or it's dishonest, one or the other. So no, Petey, you have not just debunked Nathan. You have shown that Nathan has superior understanding of these things.
His graphic is simply just showing the co-altitude angle. That doesn't mean there is no altitude angle. He just hasn't highlighted it. You're making everything out of nothing. So yes, Brian, he has just debunked Nathan. He showed the geometry, and as exactly predicted, you instantly rejected it.
And so do I. Or you're just being dishonest, one or the other. Thanks, Nathan. I'll go quiet now.
Nope. As just shown, you guys are the ones being dishonest.
Have you really, PT? Really? Well, you just measured it with a flat earth angle on screen previously.
You see, both Brian and Nathan want you to believe it's impossible to measure.
No. It's not that we want you to believe anything. You did just measure it with a flat earth angle. It was on screen. You presented it also. I'll put it back up.
First off, that is not the same angle as the one he is showing on screen right now. Secondly, that is still not a flat earth angle. Again, curvature is negligible over that small distance.
We don't want anybody to believe anything. You showed it. You're lying sack of shit. Go f*** yourself, PT. You're lying. I don't want anybody to believe anything. You're lying. You put it up on screen. It's what I said. It's a fact. Stop lying about me, you disingenuous piece of shit. I don't want anybody to believe in anything. Okay? What I've got up on screen is the facts in the matter. I didn't request your belief in them. You put them back up on screen because those are the facts in the matter. Who is this PT? I hate this. I am tired of this shit. Not asking for anybody's belief, you disingenuous. How dare you? Who are you, PT? I want a word with you. Yeah? You're lying. I haven't asked for anything from you, you liar. I haven't asked you for your belief. Lying. Don't need your belief, you stupid. It's a fact. You need to believe in this shit. That's what you need. And you're projecting that shit with your lies onto me. And I am tired of it.
Ooh, that part stung, didn't it? Touch a nerve there, did I? Oh, boo-hoo, cry more.
Seeing how angry you got over someone pointing out a simple fact about you really shows what the whole point of this actually is. You know you are running out of old talking points to support Flat Earth. You know that any Flat Earther who was actually looking for the truth at this point is no longer a Flat Earther. All you guys have is incredulity, dishonesty, screaming and yelling, insults, lies, and mockery. You guys unfortunately cannot handle the truth, and deep down, you know it. Admit it, Brian, or any Flat Earther watching this. Just note that it is not too late. That includes you, Nathan. Reality doesn't expire. However, whether you want to face that fact is in your hands, not ours.
Well, you know how you get a zenith. You have to measure those. It's an elevation angle of 90 degrees.
Yeah, sorry, John. I believe Nathan is a bit burnt out right now. Oh, and what you just said doesn't debunk the globe.
Say something, you're so boring!
It's just denying the 90.
No, he is not denying the 90. It is literally on screen right in front of you. And secondly, 90 degrees doesn't debunk the globe. Next.
That's what he's doing.
That's what I used to say, shh, don't say 90.
Yeah, because I had to set up, just before you press play, Nathan, if you got on the video, I had to set up with MC Town in that debate. Like I was saying, he was going to come up with a zenith angle. I said, yeah, but what's the angle in reference to? I mean, it's let's say 25 degrees. From what? 25 degrees from what? You know what I mean? He didn't want to answer it because he realized, hang on a minute, that would be between the vertical and the horizontal.
Brian, it is called a reference plane. How about I use one of the diagrams you guys literally use? Here, there you go. That should make it understandable enough.
I mean, so Petey's zenith angle, just like with MC Town and a few others and Charles Globe Matt. So what's your zenith angle? How many degrees are in your zenith angle? What is the maximum amount of degrees in a zenith angle? It's 90. What do you subtract from? What do you use? Use 90.
Zenith angle this, zenith angle that. Brian, just sit down and demonstrate celestial navigation on a flat Earth.
So I don't know what the problem is. The problem is they keep on trying to make geometry work on the surface of a sphere that doesn't work on the surface of a sphere. That's the problem.
It does work on the surface of a sphere, and it is being shown right in front of you, right now.
They have this belief. Me or you, Nathan, I'm not trying to make anyone believe anything. We're showing factual things.
No, you're constantly getting things wrong and lying. You guys are indeed trying to convince all your followers of incorrect information. They go on for a minute to talk about how measurements are always exact and accurate, and better than calculations, ignoring the fact that all measurements will have some margin of error, and calculations are extremely accurate. I'll skip past that.
What?
You can point straight up with one arm, and then point to Polaris with the other. Then you have all you need to prove them wrong.
No, Petey! Hello!
No words? Not surprised. That video was quite devastating to Flat Earth.
No, that was the end of the video. It was just started to play an advert and I stopped it.
Wow, that is. I didn't watch the video because I watched his last one and it was full of nonsense and there was things you didn't even understand.
No, the last one devastated Flat Earth completely. That is why you didn't like it, Brian. Anyway, they complain about how horrible the video was for a while longer, then ramble on about other stuff. I've spent enough time here. Thanks for watching.